Good morning to all of you. Today I will do problems for shear force bending mode diagram. Last class I have done problems in shear force bending mode diagram for open beam or to find out the point of contact flexure. Today also I will do some problems in this topic. The subject is mechanics of solid, mechanism of solid or strength of material. Clear? This question number 67. The question is an opening beam CADBE loaded and supported as on figure. An opening beam CADBE is loaded and supported as on figure. Find, draw the SFBM diagram. Shear force and bending moment diagram. Look at the point of contact flexure. The point of contact flexure, if any. Clear? This is opening beam CADB loaded 3-point loads or concentrated loads 50 kilonewton, 40 kilonewton, 25 kilonewton, and two reactions at A and B. This is RA, this is equal to RB. Clear? Draw the shear force bending moment diagram for the beam and find, locate the point of contact flexure if any. Clear? Now first find out the reaction at A and B, then make shear force calculation, then make bending moment calculation. Clear? Let RA is equal to reaction at A, RA. RB is equal to reaction at A, B. Clear? RRB. Now, sigma y0. RA plus RB is equal to, clear? 15 plus 40 or 25. 80 kilonewton. Equation 1. Equation 1. Now take amount of day. Sigma about A, RA passes, its moment is 0. So RB into 5 plus 15 into 2. RB into 5 plus 15 into 2 is equal to 40 into 2.5 So 25 into 6.5, 40 into 2.5 plus 25 into 6.5. Clear? Now find RB. Now from this equation, we will find RB is equal to 46.5 kilonewton. RB is equal to 46.5 kilonewton. Clear? Now from equation 1, RA is RB. RB is equal to 46.5 kilonewton. From equation 1, RA is equal to 33.5. From equation 1, RA is equal to 80 minus RB. 80 minus 46.5, 33.5 kilonewton. RA. Clear? This RA, this RB. RA, RB. Clear? What is RA is equal to 33.5 kilonewton. What is RB is equal to 46.5. Right? Now, shear force calculation. Shear force calculation. A D just right. Shear force at E just right. 0. 0. Clear? At T just left. Shear force at T just left. 25 kilonewton. Clear? B right. Shear force at B just right. Same. 25 kilonewton. Because E left, B right, no load. So B left means E left means B right. This continue from E left to B right. At B, the upper direction is 46.5 kilonewton. This will calculate for shear force at B left. Clear? Shear force at B just left. (25) minus 46.5 minus 21.5 minus 21 kilonewton. Clear? B just left. Then minus 21.5 kilonewton. Next, B just left. B left clear, then D right. Shear force at D just right. Same. Minus 21.5 kilonewton. Same, just D right same. Clear. D left plus 40 kilonewton. Shear force at D just left minus 21.5 plus 40. Clear? Minus plus 18.5. 8.5 kilonewton. Then A right. Shear force at A just right. A right. Same. D left and A right. 18.5 kilonewton. Then A left. Shear force at A just left. A left. 18.5 minus 33.5. Clear? Is equal to minus 50 kilonewton. Then C right. Shear force at C just right minus 50 kilonewton. C left. Shear force at C just left minus 15 plus 15 0. Right? Now take scale. Take scale 1 cent 10 kilonewton. Scale 1 cm is equal to 10 kilonewton. Now mark a points A, B, C, D that put the values. C, A, DB, DB is just at 0. Is just at 0. Is just left plus 25. This is 25. B just right plus 25. Clear? B just left minus 21.5. 21.5. D just right minus 21.5. Right? D just left plus 18.5. Just right 8 5. A just left -15 -50 kilonewton. C just right -15. C just left 0. Clear? Now join all the points. This is E just right 0, 0, 25. Then E just right 25, 0, just left 25. B just right 25. Then B just left minus 21.5. Clear? B just right minus 21.5. B just left 18.5. Clear? A just right 18.5. A just left minus 15. C just right minus 15. C just left 0. Clear? This is SHEAR 4 diagram. Now this is positive value, this is negative value, this is positive value, this is negative value. So 2 points A and B. At 2 points A and B, the SHEAR force changes sign. So at these 2 points, the BM is maximum. Clear? Now maximum design. Negative, positive. Clear? So now at 2 points A and B, the BM will be maximum because at these 2 points, the SHEAR force changes sign. So distance of 2 points are known. So first make BM calculation. BM calculation. Now it is 0. BM at E 0. Clear? At B, BM at B is equal to this 25 to 1.5. 25 into 1.5. This will be 30.75. 37.5. Minus 25 into 1.5 is equal to minus 37.5 kilonewton meter. A D B a D BM at a D. This is point D. Clear. This is 25 to this minus RB to this. So 25 into 4, 25 into 4 minus RB into 2.5. Clear. This is 25 into 4 minus RE means 46.5. Clear. A D. BM at a D. So this answer may be D 16.25. 16.25 kilonewton meter. D at a BM at a. This is point A. About A, this array amount 0. So 15 to 2 minus 15 to 2 minus 30 kilonewton meter minus 30 kilonewton meter. At A, C0, at C0, BM at A, C is equal to 0. Clear? Now draw the diagram. All point loads, just inclined straight line maybe. First I give the points. C, A, D, B, E. Clear? Now at E0, E0, at B just B minus 37.5, 37.5, at D 16.5, at A 30, C0, 0. Now clear. So the bending mode changes sign at this is P1, this is P2. Clear. So P1, P2 are called point of contact temperature. Now we'll find out the value of P1 and value of P2. Now the BM changes its sign, at P1 and P2. P1 and P2. Clear? At P1 and P2, the BM changes sign. So these 2 points are called point of counterfluctual. Clear? These 2 points P1 and P2 are called point of counterfluctual. Clear? Now we'll find out these 2 points. Suppose this is y1, this is y2, this is y2. At this point, the BM is maximum. So, to find the value of y1 and y2, find BM at P1 equal to 0, BM at P2 equal to 0. Clear? Now, P1, P2. Now, this is P1, P1, this is P2, P2. Clear? P1 and P2. Now, P1 is a distance y1 from a, this y1. This y2, y2. Clear? Find bend moment P1 equal to 0. We'll find y1. Bend at P2 equal to 0. We'll find it y2. Now, clear? Now, at P1 for y1, for P1, that is y1, that is y1. Now, BM at y1 is equal to 0, P1 is equal to 0. Clear? So this into this. What is this? 15 into 2 plus y1 minus 15 into 2 plus y1 plus r into this plus r into y1 0. Clear? Now, what is r? 33.5. So minus 15 into 2 minus 15 into y1. What is r? 13.5 into y1 0. Take this side. So 13.5 minus 15, 80.5 y1. Clear? Is equal to 30. So what is y1 is equal to? 30 by 80.5. 30 right? So y1 is equal to y1 1.62 1.62 meter. Similarly, you find out y2. Clear? y2 for p2, that is y2. Clear? Now this y2, so bm at p2 0. For calculating y2, bm at p2 is equal to 0. Right? Now this and this minus this 0. So 25 into 1.5 plus y2, 1.5 plus y2 is minus 25 because right clockwise negative, plus rb into y2 0. Clear? Now minus 25 into 1.5 minus 25 into y2, what is rb? 46.5 into y2 0. Clear? Bring this to this side. So 46.5 minus 25, 21.5. So 21.5 by 2 is equal to 25 into 1.5, 37.5. So y2 is equal to 37.5 by 21.5. This may be less than 2. 37.5 by 21.5. This may be 1.74 meter. So y2 is equal to 1.74 meter from B. Clear? This is y2 from B, y1 from A. This is point of contact fracture. Clear? This is base diagram, this is shear force diagram, bending moment diagram. This is SF diagram. Clear? This is BM diagram. Clear? Now next I will do question number 68. Clear? This is question number 68. Last question is shear force bending moment diagram. Next class I will start bending stresses in beam. Clear? This is question number 68. The question is a simply supported beam, means an overhanging beam loaded and supported. Point load 4 kN and UDL of 2.5 kN per meter over central length. Draw the SFBM diagram for the beam. This is reaction at B RB, reaction at C RC. Clear? First find out the reaction at B, reaction at C. Now the question is an overhanging beam. Overhanging beam ABCD is loaded and supported as on figure. As on figure. Clear? Draw the SF and BM diagram for the beam. For the beam. Clear? Now first find out reaction at B RB, reaction at C RC. Let RB is equal to reaction at B, RC is equal to reaction at C. Clear? Now this you tell 2.5 kilonewton per meter. 2.5 kilonewton per meter. Right? The total load is 2.5 into 8 because the total length is 8 meter. Clear? So this is 2.5 into 8 means 20 kilonewton. Clear? This is 4 meter. This is 4 meter. Right? Now sigma y0. Upward force is equal to downward force. What is upward force? Sigma y0 means upward force. What is upward force? RB plus RC is equal to 4 plus 20. 4 plus 20. RB plus RC is equal to 4 plus 20. Clear? 24 is equal to 24 kilonewton. Now take boundary either about B or about C. Let us take boundary about B. Sigma MB0. About B, RB passes about B, its moment 0. Next, RC into 5, 4 into 2 is equal to 20 into this, or this length, 2. This is 4, this is 2, this is 2 meter. Clear? So RC into 5, RC into 5 plus 4 into 2 is equal to 20 into 2. So RC into 5 is equal to, this is 40 minus this 8, 32. What is RC is equal to? 32 by 5 is 6.4. 6.4 kilonewton. So RC is equal to 6.4 kilonewton. Now RB. From equation 1, this is equation 1. From equation 1, this is equation 1. What is RB plus RC is equal to 24. RB plus RC is equal to 24. What is RB is equal to? 24 minus RC. So 24 minus, what is RC? 6.4. 7.6 kilonewton. This is RB. Clear? RB is equal to 7.6 kilonewton and RC is equal to 6.4 kilonewton. This is 4 meter. Clear? This is 5 meter. This is RB. What is RB is equal to? 70.6 kilonewton. This is RC. What is RC is equal to? 6.4 kilonewton. Clear? So now make calculation for shear force. Now D0. Shear force at a shear force calculation. Shear force at a D0. Let C just write. Shear force at a C just write. At D0, let C just write 2.5 into 1. This is 2.5 into 1. This is 1 by 2. 1 by 2. Clear? This is write down a positive 2.5 2.5 into 1 2.5 kilonewton. C just right. Let C just left. Shear force at C just left. This is C just left. C just right 2.5 plus 4.1. C 6.4 minus 2.5 2.5 minus 6.4. Clear? She just right 2.5. She just left 2.5 minus 6.4. 0.9 3.9. She just left. Then B just right. B just right. First D, then C, then B. B just right, B just left. Shear force at A, B just right. .9 minus 7.6. 3.9 minus 7.6. This may be This is minus 3.9, minus 3.9, B just right. She just left minus 3.9, B just right, minus 3.9 plus this. What is this? 2.5 into 5. 2.5 into 5. This is minus 3.9 plus 12.5. Clear? Minus 3.9 plus 12.5. The value is minus 3.9 plus 12.5. 2.5 into 5. 2.5 into 5. Clear? 12.5. So 12.5 plus 3.9 minus 3.9. 8.6. Clear? 8.6 kilonewton. At B just right. Clear? B left. Shear force at B just left. Shear force at B just left. 8.6 minus just left 70.6. You use calculator for solving the problem. 8.6 minus 70.6 minus 9 minus 9 kilonewton. At B just left, A just right. Shear force at A just right. Minus 9 plus this. What is this? 2.5 into 2. This is 2.5 into 2. 5 kilonewton. Right? This is 5. So minus 4 kilonewton. At A just left. SF at A just left. Minus 4 plus 4. 0. Clear? Now, I am not using calculator. So you use calculator to find the correct answer. Now draw the shear force diagram. A is B, C, B. Now take scale 1:1 or 1:1 Newton 2 cm. Take scale 1 cm is equal to 2 Newton, 2 kilonewton. Clear? Take scale 1 cm is equal to 2 kilonewton. Now D0 at C just write 2.5 plus 2.5. She just left minus 3.9 minus 3.9. B just right plus 8.6 kilonewton. B just left minus 9 kilonewton. A just right minus 4 kilonewton. A just left 0. Clear? All positive values taken above the baseline, the all negative values are taken below the baseline. Clear? Now join all the points. All the points. First D0, C 2.5, again C left and minus 3.9, again B right 8.6, again B just left minus 9, again A just right minus 4, A left 0. Clear? Now we have joined all points. Make some design. This is negative side, this is positive side. This is negative, this is positive. Right? So this is plus, minus, plus, minus. Now the shear force changes sign at point A, B and C. So at these 2 points, the BM is maximum. Clear? First find out the bending moment at all the points A, B, C, D. Now BM calculation. BM calculation. Now at D0, BM at D0, at DBM 0. Clear? Let's see 2.5 into 1 into 1 by 2. Let's see 2.5 1 into 1 by 2 minus negative. So minus 1.25 kilonewton meter. Clear? At point C, at point B, Let B 4 into 2, clear? 4 into 2 minus this, minus 2.5 into 2 into 2i2. This 8 minus 8 minus 5, minus 13 kilonewton meter. Now BMT, this is also change the sign. E, it is also bending on the maximum. This is point E. Clear? So this is BMT B at a 0 is equal to 0. First find the value of E. Now suppose the point E is its x from B. This is 5 minus x. 5 minus x. Clear? So x is equal to, we'll find the value of x, and x is maybe now put values, then I will do find out value of x. A, B, E, C, D. Clear? Now a D, BMA D is equal to 0, 0. At C is equal to minus 1.25. Clear? Minus 1.25. D will find out, at D will find out. At B, minus 30 kilonewton. Minus 30 kilonewton meter. It is 0. Clear? We find out the value of x, that is the position of E. Position of E means value of x. Now compare these two triangles. This is triangle, this is triangle. Compare these two triangles. So x by 8.6, 5 minus x by 3.9. Clear? Make solution, x is 3.44 meter. Make solution, will get x is equal to 3.44 Newton meter. Now BM at E, at E, at E, come from this side. This x, Clear? So 4 into this minus this into this plus this into this. Clear? Now this is x is equal to 3.44 meter. Now BMT is equal to RB into this. What is RB? RB into x. Clear? Minus 4 into 2 plus x on this. Clear? Minus this 2.5 into this 2.5 into 2 plus x minus 2.5 into 2 plus x into 2 plus x by 2. Clear? So this is RB. What is RB? 7.6, 17.6. So BMT is equal to RB 17.6 into what is x? X value to 3.44. 3.44 minus 4 2 plus x 2 plus 3.44 minus 2.5 into 2 plus 3.44 square by 2. Clear? So BMT find out BMT, its value may be 1.792 kilonewton meter plus now join all the points. This is 1.792. All are parabolic. Clear? For join D to C, then C to E, then E to B, then B to A. Clear? Here also two point of contact picture between B and E, between E and C. Clear? So 2 point of contact picture. This is P1 is equal to P2. Clear? Last question I have done. I find out 2 point of contact P1 and P2. In similar way, you will find these 2 points P1 and P2. Clear? You do this problem similar way. Next class I will start bending stress in beam. You practice all these problems, and in the similar way, last question I have already found out 2 point of contact fracture P1 P2. In this way, you also try to find P1 P2. Clear? This is our question number 68. Now I will start next class bending stresses in beam. Thank you. Please make like, share, subscribe to all our channels. Thank you.